To be able to use your system once you assemble it, you can't just plug it in and put load on it. You got to follow these steps. We put it as the steps on the page of the MaGrav when you open. First of all, you have to check that you have the right polarity. What does this mean? You have to have the life of your wire, you call it phase, to be connected to the live and the phase of your load, which means your system, when you do check, you got to find out which one is carrying the load, the power, you mark it, and then you go to your plug or to your power supply and you plug the same. You find out at your power supply if it's a system like this, or if it's the main you want to adjust it or add it to, and you find that it's all the same. You connect live to live. If you connect live to neutral, you find out you might blow your system up or the system doesn't work. So this is the first thing. You have to connect your system to the right phase. The number two, which is the same understanding, is that once you connected your system to the power supply, you got to leave it for 2-3 days, maybe more. And you have to leave it at least for 72 hours for the system to settle itself, nanocoat its environment slightly. And at that point, you can add a very small LED light. Into the circuit. So you set up the initial stage of release of energy from the plasma. Under no circumstances, that's absolute no. Do not connect immediately any resistive load like a heater, any resistive load like light bulbs, which are the old light bulbs, not the LED lights, because in some countries we see no problem, and in some tests, what happened, especially the first days you connect your system, the power of the plasma is so much that it literally blows the light bulb out. You can, even if you put like a half a kilowatt or 1 kilowatt or 2 kilowatt heat resistors, you find out you could get problem with them. So initially, do not load any high power to the system. You have to allow the system to run, that it start nano-coating the wiring, that it can take and receive energy on a nanocoat layer, not on a matter state. This is where a lot of people will make a complaint. I plugged it in and it went. When you get it, understand. Get yourself non-resistive. Yes. Do what, please? Can you repeat? What do you mean use a 6 or 9 volt battery? Rechargeable battery, you mean? Ah, initial load to charge up the battery, you mean? Ah. Oh yes, no, I thought you meant to use 6 or 9 volt on the supply line. Okay, so no. So what the suggestion is, you want to use a 9 volt square batteries initially to charge, at least to start releasing the process. You got to realize you have made the system, and initially it carries a lot of power. Initially it releases a lot of power because all the gases you put on is ready to release energy. So you have to allow it to go through. We know that some people straight away plugged in the light bulb to start, light bulb with a resistance like a tungsten, and the power is so much that it blows the light out. You can actually get a blowout of the lamp. This cannot be done. You have to take a DC load initially. Leave it for about 3 days, 4 days, that the load gets used, and then you add the next step into the process. Then you put, we said no resistive load in the first 72 hours at least. Then you add another small load. You increase the load. Good morning. You increase the load to something else. Computer. No, don't use a computer because you think something happened to it. Something which is light in power, mainly uses DC. You have a small converter on it that you can run the process. Do this for about a week, that the system settles down. So you add a small second load. Again, non-resistive. After about 10 days or so, to be safe, then add a small resistive load, maybe 500 watt. Like a boiling kettle water. When you boil the water, the kettle, just add that. If some of them are very small ones, if you have a 1.5, 2 kilowatt one, please do not use, because then you have a problem. Use something very small resistive. But now, with these two, you used the nano layer for energy. Now you are using the conversion of the AC section. Yes?
Any advantages of taking more time?
Yes. If you take time, the slower, if you make it 2 or 3 weeks, very slow, then you build the system up. And system builds up. Then we always recommend you, if you receive these units, you don't understand anything about the electricity, the phase or whatever, get yourself an electrician. Let him read the manual, understand what it is, and then use it. Don't just plug it in. It will take time till the industry builds up technologies that can accommodate plasma technology. This is not electric current, this is a plasma, and it takes time. It's not going to be overnight that we have heaters that they're going to be used through the plasma AC or a DC of the plasma. So it's paramount you follow the rules. Don't, if you have a heater, a fan heater, even 1.5 kilowatt, you can use that. But if you have a heater which is just a bar, resistive bar, do not use it. because the fan of the heater usually brings balance. This is what I was discussing with the people this morning. That use, for example, even if you use a fan heater, we have used straight away here, what do you call it? A 2 kilowatt fan heater. Don't use a resistive. Anything which is resistive, like your light bulbs with a tungsten, heating element, like your, what do you call it? Not the microwaves, ovens, those kind of things will give you a problem because it takes time. In 3 weeks, 4 weeks time, you can use them, but initially you can't because they try to condense the energy of the plasma into a narrow bandwidth of the electron vibration, and they create heat. So in second week, you can use a fan heater at a very low power. Start with number 1, like 400, 500, or 600 watts, and then over a week build it up. What you are doing, you are not bringing the system into operation. You are bringing the house in order to be able to accept the system. This is where you have to watch. You are not training the system to release energy. You are in the process of the weeks creating a nano layering in your structure that can accommodate the use of energy. You will find out we will get a lot of resistance for launching this material. We've seen the first one this morning. A lot of people are trying to stop it because they could not believe that we released the technology the way we've done in the past week, that everybody is making it. Now they have tested it for non-resistive and they've seen the potential of it. They are not telling you how much they are benefiting by the non-resistive, like a LED. If you have an LED light in the house and nothing else, turn it on. It all works, no problem. It takes a day, 2, 3 days. You see the meter literally stops working. At the first day or 2, you see a slowing down of the meter. But after a week or 2, anything which is non-brush, non-resistive load will become absolutely free. Fluorescent is depends on the heating element. If there is some of them have different parameters in the background. Depends if there is a resistors built into it to be able to work. The elements, most of these systems in the front, they could be very weak resistive or conductive. And in the back, they have resistive elements. They put resistors for circuitry to be able to do whatever they want to do for their control. So the system sees those resistors as a resistor to the CD, or what you call it, to the system, to the MaGravs system. So you got to realize you are developing a new system to be able to use it. If you get it and plug it into a huge 2 kilowatt, you burn it, and then you say there is something wrong. We put in our leaflets, we don't accept responsibility because we have tested it. With it, it tells you when you receive the certificates for it. CE certificates will be released by email to you. American certificates will be released through email to you, and the same for the cars. So certification dates are released with the goods. Understand, and I'll repeat again, any resistive load, and we've seen people, they have connected directly into the plug to prove if it works 2 kilowatt, they put a 2 kilowatt resistive in it, and the resistive heater just burns out. We are warning you, do not connect any resistive load at least in the first 3 weeks till your system builds up. No way, and we have made it, we put a disclaimer on it. There is a disclaimer with the system that you're responsible 2 kilowatt, and it has to be after 3 weeks. And then you don't use a 2 kilowatt constantly. We use the fan systems. We show you that, as we said, if you build yourself a second unit, or you purchase what we call the cascade unit, but you have to give the reference of your first unit which you purchased. We put those at €250. It's going to be released later on next week. You put your original system, then after 3 weeks, add your interface of the grid. After your meter, you get an electrician to put it in series, the same phase connection, and then you place second one in the end farthest point in the house from the electric wire connection. So you have covered here. In this mode, from the second phase, and here we have seen in our test 5.2 kilowatt power resistive. So then you can build up from 2 kilowatt to 5, 5.5. If you increase the number of stackers, as you've seen with Renan, you can go to 7.5 kilowatts. So you need 2 units, 2 systems. To increase the power, you need 2 systems. Because if you remember, if you go to the Alex's system, when you put the meters on, we saw that 4 kilowatt was going out into the grid, and 1 kilowatt was coming into the unit, if you remember, where we connected the fans. Yeah, sometimes 5. Here, when you put the second unit, that's what happens. Now, the second unit is feeding the house. Instead of here, the first unit feeding the grid, now the second unit feeds the house. But you have to nano coat it completely, and then in this cascade, any amount of non-resistive LED, non-brush, fridge, freezers, that kind of thing which you use is free. 1.5 kilowatt freezers you can connect, 1.5 kilowatt fridges you can connect, and then you build it up. If your fuel energy consumption is over 3-4 kilowatt, then you need a cascade unit.